So welcome to this episode of Seen and Solved. I'm your host, Tim Pennington. Today, I'm joined by Robin Deal from Hubbard-Hall to discuss an issue that many finishers are facing today, PFAS. We'll talk with Robin about the situation with PFAS and metal finishing under the current administration and what steps finishers can take to avoid running afoul of any future wastewater limits.
You're listening to the Seen and Solved podcast, brought to you by Hubbard-Hall. Better results, less chemistry.
So, Robin, I appreciate you joining us today. We're going to talk about, I think the number one concern of what most finishers have in the back of their mind. So, certainly the owners and managers of these facilities, which is PFAS. Which if you look back, it's probably, I think, 15 years old. This has really started taking shape, but it keeps picking up more and more every year. But we're going to talk about a lot of things with PFAS and hopefully some good news of what finishers can do. Let's cut to the chase. Let's not bury the lead. What does the future hold for metal finishing and PFAS coming up in the next couple of years that you might imagine?
So, Tim, I think it's important to remember that when we talk about the perfluorinated compounds, we're talking about more than 15,000 known compounds right now, right? So this isn't just one. And they're uncovering and redefining more and more. It's not as fast as it was a year ago, but it's still happening pretty regularly that we're uncovering more and naming more as forever chemicals. And they fall under the PFAS umbrella, including PFAS, PFOA, Gen X, and the rest of these compounds. And I think a lot of people thought with this new administration in the United States, we'd see some rollback of the expected limits and guidelines that are coming, but we're not going to. And the new EPA administrator, Lee Zeldin, in February of 25, announced the 5 pillars that he is going to structure the EPA around. And pillar number 1 is clean air, land, and water for every American. And pillar number 3 is permitting reform, cooperative federalism, and cross-agency partnership. So what those 2 pillars out of the 5 mean in terms of metal finishing is that the EPA is dedicating itself to ensuring every American has clean air, land, and water. PFAS is a major concern for water because it's a known carcinogen in some of the compounds. It's a known toxin in some. It does produce low birth weights and higher risks of cancer in areas where there is extreme amount of these compounds in the drinking water supply. So we're not going to see this go away anytime soon. What we're going to see is a restructuring of how the EPA is looking at it and how they're going to define the limits. So there has been a slight pause as they look at whether best available technology for treatment is viable over what is economically available for metal finishers, municipalities, drinking water facilities to remove or destroy these compounds from the water streams. I think that's the key thing for metal finishers to remember. It may seem like they're backing off a little bit right now, but it's just not going to go away.
And you and I have talked about this before, but when Zeldin made the announcement recently about PFAS, the only industry he mentioned by name was metal finishing. And he said, we're going to do this for the metal finishing. And I think that sent a little bit of shockwaves to a lot of owners who were like, wow, of everybody out there, like you mentioned, 15,000 possible PFAS chemicals out there. It's in beer you hear now, right? But yet they took the time to say, we're going to set metal finishing. Did that surprise you at all?
To be honest, it did a little bit. I expected textiles to be one of the leading, and then firefighting foam sites to be the second, right? Because everybody knows PFAS compounds as like Scotchgard and the AFFF firefighting foam. But when we look at the history of PFAS compounds in use in metal finishing, as early as 1954, chrome plating was using PFSAs, right? So it's a very long history, and we do use high concentrations of it. So it's kind of a twofold. Yes, it was kind of a surprise, but when you step back and look at it as the bigger picture, not really. We are a heavy user of it. Even today, knowing everything we do, we still see certain compounds showing up in our wastewater.
Like you mentioned, history, it should be noted because a lot of finishers will point this out to me all the time. They were actually mandated by the EPA to use mist suppressants, which contain PFAS. So they were required to use it back in the 70s and 80s, and now they're kind of angry they're getting dinged for it now. So,
and I think that speaks a lot to our technological advances, right? When we first started hexavalent chrome plating, we weren't aware of the dangers of it. And then we learned the dangers of it, the carcinogenic effects of it. And so we said, we got to protect our workers. Well, when we came out with the PFAS, PFOA, PFSAs, we weren't aware of how dangerous they could be. And so now we are aware of it. If you look back through history, women in the 15th, 16th centuries were using arsenic and lead to make their skin look paler, right? And now we know that literally killed them.
That's right.
So it's right. Like we continually learn and we evolve. In the case of PFAS compounds, we have gotten to a point where we see what they do, and now we've got to clean them up.
You mentioned the history, and so like you said, everybody will say, well, we were required to use mist suppressants, and talk a little bit more about the history of it, because even though some people stop using the mist suppressants, or they're still using some products that contain PFAS and PFOA, correct?
Correct. So I know that some compounds are labeled as PFOA free, right? But they still have like S2FTS in them, which is a different type of PFAS, right? So we are seeing testing done on ones that are truly forever chemical free. And then we're seeing ones where they're not truly free. They're just a slight variation, enough to bring them out of that PFOA, PFOS categorization. But that chemical may still fall under the PFAS umbrella. So it's a confusing time for everyone. The new mist suppressants that are coming out, I've been told, are quadruple the usage and the expenses through the roof. And some people are being misled as to what's in them a little bit. I don't think intentionally at all. I don't want to say it's intentional. I think it's because as we're evolving and reclassifying specific compounds, we're finding out, oh, this compound is now considered part of this group, when maybe 6 months ago, when the mist suppressant was developed, it wasn't.
Let's talk about the PFAS compounds that are in hexavalent chromium shops. What describe to me the testing, the lab testing that you all did. I know you all did a study for this, or you're in the midst of it, right? Give us an update of that. What were some of the how you did the lab testing?
So we started a year ago, and earlier we spoke with Brooks from FredSense, who is the lab we partnered with, on how they are designing biochemical reaction testing techniques for the PFAS compounds. But about a year ago, we set out with a vision in mind of how do chrome platers address the PFAS compounds in their wastewater, and how can they do it economically and immediately with technology that we have now. So we reached out to numerous chrome plating shops across the country, and we sampled their water to see just what was in their water now. And we found 11 compounds consistently showed up across all of those shops that we tested. And we looked at different removal techniques for treating wastewater. that's in use right now. So we looked at traditional hydroxide precipitation. We looked at microfiltration. We looked at carbon filtration, and we looked at shops that are actually doing evaporation followed by distillation to recover their water for reuse. So with that, we saw the 11 different compounds that consistently showed up in every site. 6,2-FTS, which is the mist suppression systems. But we also saw PFBS, which is a surfactant and a defoamer. We saw PFHPA, which is another type of mist suppression. We saw PFHPS, which is a wetting agent and a mist suppression compound. We saw PFXAS, and again, that's a wetting agent and a mist suppressant, the same as PFHPS. We saw PFHXS, which was a surfactant and a defoamer. PFOA, PFOA is the mist suppression. PFOS, wetting agent mist suppression. PFBA, mist suppression. And PFPEA, which was an emulsifying agent. And then PFPES, which was a lubricant. So all of these, you see a lot of them were classified under mist suppression, but some of them weren't. Some of them were classified as they're in the defoamers. They're in the emulsifying agents that might be in the cleaners that you're using. They're in the lubricants that maybe these parts came in and had to be cleaned, and the lubricant from the forming process that was used contains that. So those were the ones that consistently showed up during our testing.
And this is the testing that you all have been, like I said, talking with a partner about and doing some things with, and just to, with a couple of shops, like you said, that you've been utilizing to kind of see how this all works, right? You got to test it out first, right?
I'm a firm believer in you can't solve a problem if you don't understand the problem. And it's real easy for people to point at metal finishing and say, you're the problem. And it's real easy for universities and academics to sit back and say, this is how we're going to solve the problem. But when you take those treatment plans and actually implement them, how do we do that successfully, right? And in this case, we didn't understand specifically what compounds are showing up. And two, what, if anything, that we're doing to treat our wastewater is helping or not doing anything at all for removing these compounds.
So let me ask you that, because I know you tested some various shops, right? You used different treatment methods. Talk about that a little bit of, you detected it, and then what were some of the shops and how some of the treatments went around?
So when we looked at all the shops, we looked at hexavalent chrome plating facilities. We looked at anodizing shops that were using a hexavalent seal for aerospace. And those were the two types. We wanted to specifically go after anybody using hexavalent chrome because we knew that's who the EPA would be targeting for their first rollout when they go into the plan, right? We followed the path of everybody that had to contribute to the survey that came out last year. And so we were very, very targeted in who we approached to participate in this. So we went from chrome shops that were very small, batch treating small batches, a couple of 1,000 gallons a day, to shops that were big and were flowing a couple of 100,000 gallons a day. And again, we collected all of the samples. Samples have to be collected in a very specific manner, and they have to be stored in PFAS-free, certified PFAS-free bottles for shipping. They have to be iced, and they have to get to the lab within 24 hours of collection, right? Because interferences and things like that. So we approached it from that angle. The AquaPure Hubbard-Hall AquaPure team did all of the collecting of the samples on site at each location, following the guidelines that were given to us by Presidents as far as what kind of gloves to wear, what kind of bottles, how to tape the bottles, that whole thing. And then the samples were sent to Fred Sense for analysis. They did follow the EPA method that tests for 42 null compounds. And out of the shops that we tested, again, we had 11 that showed up in every shop. And to some degree, every shop had those 11 that I mentioned earlier. And then there would be oddball ones that were just like one shop would have this really oddball one. So we said, okay, if we know consistently from the shops that we did test, these 11 show up, how can we remove them? And so we looked at the traditional, just straight hydroxide precipitation and saw no removal. There was absolutely no removal at all for that. We looked at microfiltration, and the removal was so minimal. So then we looked at carbon filtration, and we saw that carbon filtration removed 78% of the total PFAS, which left us, with a reasonable amount of 22% left in the effluent. And then we looked at evaporation followed by condensation for distillation. And that was the best with 87% removal.
Oh, really? Okay.
Yeah. So
wow.
it outperformed, and we expected that. We knew that would probably be the way this would trend. So then we had a hard conversation about, okay, if we have a shop that is not doing evaporation or carbon filtration, and they want to implement one of these processes, what would be the most economical way for them to advance? And when you look at evaporation, if you're not evaporating now, you have a huge capital expense to get the equipment built and installed. You have air quality testing standards you have to meet. There's maintenance of the evaporator. And it's a larger capital expense up front than carbon filtration. So again, the vision we had, what can metal finishers do now to help remove PFAS from their effluent in an economical, viable way? It was carbon filtration. That was the option we elected to go with. You're still left with a spent carbon that's PFAS loaded, and you still have maintenance costs, right? Because you're going to have to regen your bed, or you're going to have to dispose of the bed and put new carbon in. But overall, in terms of high level, what we know, how these systems work, that again was still the most economically viable option for shops who want to advance right now with a way to remove, on average, 78% of the PFAS from their waste streams.
And like I said, we don't know what the effluent numbers or limits are going to be, but at least that would subtract a whole lot of what they may be having with that, right? So, yeah. So let's talk, like I said, moving forward, what do you think the future is going to bring with looking at what you all, the study that you all did and some other issues? What do you think the future is going to mean for shops to be able to, manage the levels that they may have in their systems?
So we are advancing, moving forward with the belief that carbon filtration is the number one economic way for immediate removal. We're going to be kicking off a pilot study, hopefully in August. Right now, we're still in planning phase of it for putting in a carbon filtration pilot unit at a local customer where we can monitor long term. So we can track the data of how long does the carbon last? How much effort is it to replace the carbon? What does that look like in terms of what a customer can do? And then, so that's the next immediate phase that Hubbard-Hall is working with. Going from there, we will be offering these units for customers who want to follow that path. Then the second part of this is we're looking at what do we do with the carbon when it's spent.
You've still got I don't want to say it's not a hazard, but it really is. You've now captured it probably in a more concentrated form a little bit. What happens there? Is that something you're studying then?
Yes. So our next phase of the study will be when we have this carbon, ideally we'd like to regen it, right? So we can put it back in and continue to use it for as many life cycles as we can. But then we're going to be left with the solution that's PFAS laden. So we're looking at doing things like electrochemical oxidation a viable way to actually destroy it? Advanced oxidation techniques using the known Fenton's reaction or UV light with
I was going to
peroxide.
say UV light has been.
Yeah.
I've read some studies with that. Right.
Yeah. So that we can actually destroy it. But what's interesting, right? Because this is such an evolving world of this. There is research being done around ultrasonic degradation of PFAS compounds. We all know how ultrasonics work. Can we use ultrasonics to degrade PFAS? In the academic world, they're pretty successful at it. And ball milling, and I didn't know what ball milling was, Tim. Have you
What
ever
is ball milling? Never heard of it. What is that?
Yeah, so in academic settings, they're doing something similar to vibratory processes to destroy PFAS compounds using centered balls that are charged in a certain way. Is that a viable path for us going forward for the metal finishers? Is that something we can do? Can we use that? Most of us are very familiar with vibratory processes and how they work. So could we use that technology in wastewater as well? And then there was a very interesting talk that I happened to be able to listen to about something called thrombotic agglomeration.
Wow. Okay.
So thrombotic agglomeration is using the radio frequencies to steal the electrons that are in motion around a molecule to give you the base elements back, to give you a fully neutral base element with no charge, which in theory would break apart these long chains.
Long chains,
and just give you back the base compounds of fluorine and carbon, right?
It sounds like there is hope. And I know I've read a lot of the studies. I haven't seen anything real specific to the finishing industry, but it sounds like you're doing this now kind of behind the scenes, which could be, I know it takes time to study and see what kind of results you get so that, you can move forward effectively with people. But I guess your job is to change the name from forever chemicals to temporary chemicals, right? Because sounds like you can actually do something with them than just, before not being able to treat it and you were kind of stuck with these things, right?
Right. So I'm very excited to see what the next decade brings for metal finishers and wastewater, right? We got to look long-term, not short-term. Short-term is we have these compounds, we have to deal with them. Long-term is ideally we'll never have to use them again and we'll be able to destroy them and get them out of our environment together. For
Hubbard-Hall customers, I guess next steps would be just to sort of pay close attention to what's happening, right? And I know they, as you all, however long it's going to be to do these studies and then maybe roll out some testing. And I'm sure you're looking maybe to work with some more different people with this, but what would be the next steps for Hubbard-Hall customers on this? So
if we have a customer who is interested in participating in the next phase of the study, just let me know, reach out via email, phone call, on our web chat. Hop on and saying, hey, I'd like to talk to Robin. Can you put me in touch with her if you don't know how to get in touch with me directly? And we'll set up a meeting and discuss where you're at and what you want to see and how we can get you there.
Well, like I said, you bring hope. Congratulations on that. And I'm sure we'll be talking more about this as it evolves. I think the next year is going to be really important in this topic because some things are probably going to come to fruition from the government level, from the study levels, the research that you all are doing. But I'm sure this is something that we're going to be talking about a lot more in the future, hopefully with some even better news. So, but appreciate you joining us and sharing all that great insight with that. Things that we probably wouldn't have known, all that you all are doing.
Thank you, Tim. I'm always happy to talk with you.
Thanks for listening to Seen and Solved by Hubbard-Hall. For more episodes, visit hubbardhall.com or wherever you get your podcasts. Be sure to like and subscribe, rate and review, and join us on social media. Produced by Awcast.